Welcome to this Autodesk engineering workflow demonstration. Let's take some time to talk about great technology that is revolutionizing the future of making things. The example we're looking at is a high-performance vehicle made by Briggs Automotive Company. We're focusing on the Pedalbox to highlight the power behind Autodesk for design and secure management of your intellectual property. BAC, like many other companies, partners with several suppliers who use various CAD systems to design their components. Inventor 2016's AnyCAD technology enables designers to use files from all major CAD systems without the need to translate the geometry. Here we'll use a cylinder modeled in SolidWorks. Simply choose the file and drop it in the Inventor assembly. Just like any other file in the Pedalbox, if the SolidWorks file is changed, it is updated here as well. Next, we'll use joints to place it on the cylinder mount. In a few minutes, we'll make a change to the SolidWorks model and watch it update instantly in Inventor. Before we continue designing the Pedalbox, let's get the assembly drawing started. View creation in Inventor is fast and intuitive. Change the scale of the views by dragging the border or type it in manually. It's your choice. Other views can be propagated directly from the front view, even change the orientation of all the views on the fly. Manufacturing and assembly drawings are now clearer than ever with the ability to hide and show hidden edges or display the components with color. Automated BOMs display any information necessary for manufacturing, such as the part number, description, material, you name it. It's fully customizable and always up to date with changes made in the assembly. Even the balloons are created for you so you never miss a component in the drawing. They can be aligned in any direction, even use existing entities to align them to the orientation of the components in the view. Let's talk about sheet metal. We have a new design for the throttle mount on the far right that is designed as two pieces of sheet metal welded together. Inventor 2016 provides the ability to design the two sheet metal components as a multi-body part. This is a big time saver as opposed to working with the two components in the assembly environment. We have the first sheet metal body saved as a step file from another CAD system. Even imported bodies can be quickly changed or converted to sheet metal components. The thickness and bends are automatically detected, and the part is ready to be flattened. Many companies have existing DWG drawings of components they have already created using AutoCAD. Here we'll take advantage of a detailed drawing for the other sheet metal body using DWG underlays, new in Inventor 2016. Layer capabilities are available to turn them on or off for optimal clarity. Everything in the drawing is associative back to the AutoCAD file. If any changes are made, it is reflected back here in Inventor. Before using the entities to make the model, we'll position the view next to the other sheet metal body. Inventor contains selection options to quickly choose loops or single entities that are used for feature creation. Dimensions can also be added to the view and used as parameters for feature definition. With that said, let's extrude the front profile and refer to the depth in the right side view. We can also copy and move other sketch profiles and complete the 3D model. The extrude command does more than add material or cut into a solid. It also contains an intersect option, leaving behind the interfering solid. Now that we have our body created from the DWG underlay, let's go ahead and show it in a flattened state. Inventor has the ability to create additional features while the model is folded or unfolded. For example, we're going to remove some of the material in the center of the design. Once again, taking advantage of the DWG underlay. Utilizing legacy drawings is now better than ever with a direct link to the 2D drawing. The relationship between AutoCAD and Inventor is unmatched by any other 3D modeling CAD software. Let's create the cutout and finish the sheet metal body with corner rounds and chamfered edges. With the part folded back up, you can see all our changes have propagated nicely. And remember, we still have the other body, which we'll show. Multi-body sheet metal parts can also be saved as a Weldment Assembly. Because we're using Volt, it will ask us what type of component this is, using our customizable part numbering scheme. Part numbers are also prompted for each of the solid bodies included in the design. Notice the new assembly and part names have been generated for all three files. Let's finish the weldment with some weld beads between the two components. There are several options for various types of welds. Choose the location, size, and contour. Use settings for intermittent if it pertains. Even create weld symbols which will show up in the production drawing. Back in the Pedalbox assembly, let's replace the original throttle mount with our new design. With the weldment open in its own window, we're going to insert another anchor nut. Here's how we brought in the first one. We'll use the option to insert from the vault. Finding files in any CAD system can be a time-consuming process. Designers typically spend 10% of their day just browsing for files, sometimes unsuccessfully, which means there are parts that are drawn more than once. By using Vault, there is the ability to search via any property of a file, including description, who modeled it, when it was modeled. There are several ways to find the data that you're looking for. Then we'll use a couple standard mates to place the component. Notice that the anchor nut contains 2 rivets to fasten it to the sheet metal component. Autodesk Inventor enables users to create the holes for the anchor right in the context of the assembly. Simply click on the part to edit and refer to the rivets in a new sketch. Reduce scrap by ensuring holes that show up in the detail drawings are never misaligned during assembly. The hole feature creates all kinds of holes for fasteners. They can be custom sized like the one that you see here, or use the option to choose the fastener size as well. We have one other sheet metal component to finish in this assembly. It is the protection plate, and the base sketch is started for us. Notice Autodesk Vault asks us if we want to check the assembly out before making changes. This way designers working on the same project won't overwrite the work we're putting into the design, and they can see who's currently editing the file. The bends can be applied in various ways when creating flanges. First, we have a portion of the flat pattern. Adding a bend is simply a matter of using a sketch line segment. Create the line from scratch, or in this case we'll use the bend line from the original sketch profile. The fold feature contains settings for direction, angle, and fold location when the line is describing the inside or outside of the bend. We also need a flange on the other side of the part. Simply choose the edge and parameters for the angle and length. Inventor 2016 now allows 0 radius bends, which we'll use here. And that wraps up the throttle mount. Let's go back to the Pedalbox assembly and make one more update to the design. Let's take another look at the cylinder that we brought into our assembly that came from SolidWorks. Remember, this is a live link to the native CAD file. The one we have here has a 10-degree angle to the mounting bracket. We have an updated cylinder that makes these faces parallel. Let's go ahead and copy and replace the one we are currently using in the design. Notice the browser is indicating a change has taken place. All that is needed is a rebuild in Inventor. Again, no translation has taken place. The new file is up to date in this assembly model as well as the drawing. Even the property information comes over so the file can be searched in the vault, and the description for the cylinder mount shows up properly in the assembly bill of material. Finally, let's check the changes we made back into the vault. We have completed the design for the Pedalbox assembly using a few of the great new features in Autodesk Inventor 2016. The AnyCAD technology enables us to use vendor components from any major CAD system without the need to open and translate the file. Multi-body sheet metal helps us to model assemblies faster than ever with the additional productivity enhancements for sheet metal design. Autodesk Inventor is your trusted solution for the future of making things.